When most people think about corals or reefs, footage like this doesn't usually come to their mind. It's more likely to be tropical, clear water with large structure-forming coral. But they may not realize that coral reefs exist in other places, like the colder water offshore the Maryland coast. They just look a little different. These underwater structures are often teeming with life, seen here with mussels, snails, sponges, ascidians, and the white star coral scattered around. However, the 3D habitat comes in with this orange coral named Leptogorgia virgulata, or the sea whip. This is the memorial barge about 10 miles offshore Ocean City, Maryland. As you can see, it is covered with these sea whips. Sea whips are a soft coral, meaning they do not have a calcium carbonate skeleton. That's why you can see them moving with the current. You can also see their white polyps protruding from the outer orange tissue, which they use to get food. These corals provide a complex 3D structure in an otherwise flat and open seafloor habitat. This means they may serve as an essential habitat for a variety of economically important species like black sea bass, tautog, and lobster, all of which I have seen at the site. Unfortunately, we don't know much about local reefs nor the corals that comprise them, or even where they're all located. That is why my research is focused on investigating the distribution, age, colony complexity, and growth of sea whips in the Mid-Atlantic region. Here is a map of the 2 study sites I visited and removed corals from in 2017. For reference, the Ocean City Inlet is on the left. All of my sites will be located on the continental shelf. Memorial Barge is about 55 to 60 feet deep and where I tagged corals for the growth study. South Ledges on the right is about 70 feet deep and where the footage of my methods is located. I plan to add 2 new study sites in the summer of 2018 at greater depths of around 100 feet or more. Here, you can see my advisor and I performing a size frequency analysis of corals at one of my study sites. It's important to measure from the very base of the coral up to the tip of the longest branch. Every half meter, we measured the closest coral to the transect. This helps us determine the number of corals we should take from each size class at the site. We collect corals to bring back to the lab to gather total length, colony complexity, and age data. You want to cut them as close to the holdfast, or the very bottom, of the corals as possible. Sometimes this involves removing mussels or rocks that get in your way, as you can see here. The end goal of all of this work is to create a baseline of information to compare future coral changes to, whether human or naturally caused. That way, we can get an ecological snapshot of an otherwise understudied yet economically vital species in the Mid-Atlantic.